All right, so 10 minutes. I'm gonna cover this pretty high, and then we're happy to discuss more afterwards as well. So, really, we're gonna talk about AI roles and how you actually execute with AI roles, so that we can get better engagement across our resources and also just better expectation setting, which is something that we found to be a challenge. Quick background for me: I've been doing this for 25 years. I've done pretty much every role you can possibly do, mostly developer, then architect, then a lot of development management. I've done corporate leadership, and I've done every other role that you can possibly think of: requirements analyst, tester, DevOps person, probably like a lot of us in the room, frankly, right? I like that kind of variability. I've done this for big companies and small companies, and I'm often known for being a process nerd who loves to talk about Kanban, so just be careful. So I like this aspect of doing wearing a lot of hats, but it does also create some challenges. So when we don't really understand what roles we're trying to do, it creates a lot of challenges. We've been doing Agile for a long time, and like I said, I suspect a lot of you are like me. You've worn a lot of hats on different projects all at the same time or across as the projects changed. And that's really great because you're going to have deep subject matter expertise, but you can also be serviceable in a number of other areas. It gives you great resource fungibility when you're executing the project. I don't need to get 5 DBAs and 4 software engineers and 3 UI folks. I might need some specialists, but I can intermix them with generalists, which also just makes it a lot easier for me to run my project. And frankly, I think we probably all know that when we plan the projects, they never go according to how we think they're going to go. So having some resource fungibility helps us to react to that. So we all really like that. It also creates new challenges and opportunities to grow, which I think is also something that's really great. However, sometimes the company or the manager or the employee starts to gets a misunderstanding of the nature of a role, either because we didn't really understand what it was. Certainly has happened to me as a manager, or my skills weren't what I thought they were in a certain area. Also happened to me as a performer, right? So this kind of role confusion can create stress for you, the employee, for the project. It can create underwhelming results sometimes when you have to learn or you're behind the 8 ball. And it also sometimes can create salary to skill ratio problems where you hire somebody who's a really great fit for your company, but maybe you just paid them too much. Or the inverse of that, where I hired somebody who's really great, but now it's hard to pay them enough to justify them without being unfair to other people at the company. So there's a lot of challenges that happen when we don't really understand roles. This isn't just in software. This is my golden retriever, Archer. He weighs 100 pounds. He loves food. You get to be 100 pounds plus or minus 10 at any given point by having a lot of food. And when my daughter was little, he would just stick his giant head right in front of her at the dinner table, eat everything that was going on. And then she gets no dinner, he eats the dinner. We tried to fix this. I watched Caesar Milan, the Dog Whisperer, repeatedly. I read books. My wife read books. We tried everything in these books, but this feeding frenzy and the size and him stealing food, it continued to happen. So while I'm a specializing generalist and I think I can pick things up fast and do them and do a really good job, sometimes you got to know when you've met your match. So instead, I called the dog trainer, and 5 minutes after he showed up and actually worked with the dog, all of these habits were gone. And then he proceeded to tell me, by watching me for 30 minutes, the 15 things that I was doing incorrectly just from watching me in 30 minutes. So I learned a lot. I'm still not a dog trainer, right? I've learned something, but you got to know when you need a specialist and when the specializing generalist can work. And this is going to be especially true in AI, where we're more prone to role confusion. There's a lot of reasons for this. Number one is that the clarity is just not there. The terms haven't really been normed. We have limited runtime, right? So what's a machine learning engineer versus a data scientist? I can almost promise if we went around the room and asked everybody, we'd get different answers. I can tell you from performing on a lot of AI projects that on the individual project, amongst leaders, amongst people performing, you get different answers a lot on this. And this is across companies, across organizations. We see this all over the place. So there's also, what do the skills do? A hot topic for me that I hear about a lot is, should my data scientists know how to use Git? This is actually like a 50-50 proposition, which I think if you're a developer is pretty shocking. How can you not check in your source code? But a lot of data scientists think that's not their job. Their job is to do the science, to figure out what's going on. And I can see that from their perspective. There's not a right or wrong here, but there is a misunderstanding and having to come to common terms, which is the challenge. This gets harder with AI because it's in such demand that people just want to sop up those AI resources. So they're a little bit more willing to say, you know Python, you're a data scientist. You know Python, you're an MLE. I've encountered a Python developer who actually had 0 years of experience, who had a senior in front of their name, right? And then got staffed on a project as a senior data scientist and then was struggling to get through this because of this role confusion. So we see this a lot. Our approach at Codify IQ is that this is not that hard. If you take some traditional software approaches, you can actually map these things pretty well. Not everybody's going to agree with what I have up here. And if you'd like the details behind what I'm saying, we have a blog post that's linked up here that you can find. But we tend to think of a data scientist a lot like a traditional software architect, somebody who's going to come in, look at the data, look at the size, the shape, the quality, help you figure out what models might be good for this, or what kind of data processing do I need to do to turn this into something that we can work with, what's appropriate. They might actually do some prototyping, figure out what's going on, a lot like an architect would typically do, help you build your candidate architecture. They're helping you build your candidate model, your candidate data science. Machine learning engineers and data engineers, we tend to think of as more like developers. A machine learning engineer can take that science that the data scientists put together and help turn it into an engineered product that you can actually run. And data is the lifeblood for AI. So you need data engineers who can also bring things in. We see a lot of DevOps engineers hoisted into data engineering roles, which is also a challenge. That's another common role confusion we see on AI projects. For MLOps engineer and data ops engineer, those are the closest match probably, but there's still some differences. In our quick talk today, we won't get into those, but that's a pretty close one. When we do this though, something else interesting happens. We find some roles that maybe are missing. And the one we see missing a lot is business analyst. Who's collecting the requirements? I hear this a lot. Oh, this is too complicated. Only the data scientist understands what's going on. I don't need a business analyst. Well, who helps you do testing? Who's actually talking to the client? That often ends up being the data scientist or somebody else who just happens to have good client skills on the project. So we can also find what might be missing on our project when we go through and look at the roles. This helps us also turn around and say, how can we use what we already know about software delivery to help us deliver AI? Because if we understand these traditional roles, it's easier to figure out what we might need to expect from an AI role that's a little different. Roles are also impacted in AI by what you're trying to do, which I think is something that is also easy to lose. A specializing generalist is probably a great person. I can take an object model that looks for cars, planes, trucks, buses, people, something that's been pre-trained and is really great at doing that. You can go on Hugging Face, you can find 30 of them that are all awesome at that. You don't need to do reinforcement learning. They're going to do exactly what you want. That's something I can do. I don't need a data scientist. However, if I want to take that same object detection, I want to maybe drive a car with the objects that I'm detecting. Now we start to get into some new things. Maybe now I need to check for adversarial AI. Maybe I need to do some multimodal aspects of this, taking multiple sensors and doing AI on those together. Whenever there's training, reinforcement learning, looking for concept drift in your models, or looking again for adversarial AI, you want to do that. There's a famous story, I don't know if it's true or urban legend, that Tesla suffered some adversarial attacks. Again, I don't know that this is true. I've just heard this from a number of people where somebody put Post-it notes on a stop sign and fed that into their model and told it that means go. And so this is the kind of adversarial AI challenge that you can have. Real things like this are happening in the AI world. So then just to summarize this back, I think for us, AI is still software delivery. It's the latest incarnation. I think it's the most complicated when you start to have training and automated redeployments. So it's taking all the other things that we've done and it's adding this new layer on top, but it's still software. And if you understand the roles that teams need to be successful in delivery for software, you can deliver AI. But if you sit down and say, hey, we're just going to write this notebook and we're going to put that into production, you might have some problems. That's great for science, but that may not work as well for you if you have, let's say, like you're making a DoD decision on, is this a school bus or a tank? I probably need something that's a little bit more well thought through than a notebook that doesn't have regression testing and can't be deployed by anybody but one person. And we see a lot of these things that we used to see with software. We're seeing those 20, 30 years ago, Dreamweaver was going to be how you built all of your UIs. Nobody does that anymore because we all know that doesn't work. Drag and drop UIs create spaghetti code. It's not gonna work for your enterprise handoff. So this is just looking at like some traditional like RUP-like look, but you can do whatever process you like: requirements, architecture, implementation, test, operations. These things are important. If you can connect the roles to what you already know, which are all of these things as software engineers, you can have successful and smooth AI delivery. And that is all I have. Any questions? Yeah.
It seemed on your last chart that test is important, but it's just mentioned. Do you proportionally see tests being significant in terms of how much effort is put into it, or was that little graph kind of appropriate?
No, I think it's more important. I would actually say in delivery, and Eric's going to get into this just a little bit as well. We think traditional unit testing and integration testing still has a big place in your AI delivery, and then also just traditional regression testing, human in the loop testing as well. It's more complicated because it's not always deterministic in the way that we traditionally think about it, but we definitely think that's a very important part. This was just my I probably didn't give it as much billing as it deserved here. Yeah.
If one day AI progresses so much that AI will be generating AI projects or AI will be doing it, then how do you see these roles evolving?
I'm probably a skeptic on that, to be honest. So I may not give you the best answer. I think there's we might get there at some point, and hopefully if we do, I think all these things will have had to happen to get to a spot where the code you're training your AI on to write code is good enough to work. I'll just say for coding now, I think one of the problems we have is that most open source code, if you go look at it, including some I've written, is not awesome. And that's what they're training a lot of these models on. And so I think there's a long way to go to get really high quality development logic out of AI. Just my take. Yeah.
Well, we know that the trends are really changing in a week basis. Like we could talk with data science people, and they build out a model and they give a name, and then even within our, when we interview them and when we have the conversation, they say, yeah, the name and the logic is that way. It could be changed tomorrow. So in that kind of really changing landscape, which is so much dynamic,
right,
how we can cope up, like there are so many changes are going to come maybe within 6 months that whatever we have written or whatever we have taught like 6 months ago, it's going to get changed. How we can cope up, maybe the data science will come out with something else.
They might, and this happens all the time. Models come and go in terms of what's the best one for object detection, and what you're trying to do is a good example. That's why there's 30 of them on Hugging Face. It depends on what you want to do. I think this comes back to just traditional architecture and traditional patterns. What I think is happening right now is a lot of, I built this thing in a week and then I put it out there, and I'm using the fact that it might change tomorrow as my justification to not do a good job, or let me say like a thorough job that I would be expected if it was a website or a mobile app, something a lot less complicated. And so we use that logic sometimes, and then we push those things out, and then they change. And right now we're getting away with it because the pace is fast and nobody's noticing. My personal prediction is that you're going to see some big failures happen before too long, and they'll be very public. And then we're going to start to hear more from industry and the government on what they expect, just like they do for security and pretty much anything else. But it is a big challenge because the pace is so fast. People want to keep up, and it's understandable. But I think architecture and pluggable designs is the way to help you achieve that.
Awesome. Thanks, Ryan.
Yeah, thank you.
Just the tip of the iceberg, a brief voyage through Azure AI Machine Learning Studio. So today we're going to learn, we're going to train a model using Azure AI Machine Learning Studio. Obviously, this is going to be a quick demonstration. Recently, Gehl, our CEO, and I have been working on machine learning proof of concept for a customer using Azure as their cloud infrastructure. We had a chance to use the Azure AI Machine Learning Studio in this machine learning journey. So this presentation is going to be a brief voyage through Azure Machine Learning Studio, and we're going to show you how I could quickly train a model using the studio. So what is Azure Machine Learning Studio? So Azure Machine Learning Studio is an enterprise-grade machine learning and AI service, end-to-end infrastructure, provides a lot of capability. So you can think of it as machine learning as a service. So some of the features of Azure Machine Learning Studio. So of course, we start with data. So we can ingest and store data from a variety of sources. Notebooks, so supports Jupyter notebooks. That's pretty ubiquitous if you've done machine learning or any of the data science. A designer, which is a drag and drop interface for creating pipelines for machine learning. Prompt flow, which is a automation of AI and machine learning. Generative AI. AutoML, which is what we're going to focus on today, which automates the machine learning process. models or publishing models. So once I've trained my models, I can publish it out to Azure Machine Learning or the Azure infrastructure to be consumed. Compute, which provides CPU and GPU-based resources. So obviously the Azure cloud infrastructure gives me a lot of options there. And then endpoints, which allows me to publish my models so I can do inferencing and testing of my models using REST endpoints. So the focus again today is just on auto ML. So there's a lot of features for Azure Machine Learning Studio, but I want to focus on auto ML today. So real quick, you might recognize this if you've done machine learning. This is the general process for machine learning. So of course, you're going to start with your data, loading your data. There's a lot of cleaning and transforming of data. If you've done any machine learning, data itself, when it first comes in, is not ready to be trained through your model. So you're going to do some cleaning, transformation, and EDA, which is exploratory data analysis. A lot of that happens outside in Jupyter notebooks and a lot of the Python libraries. Then we're going to take that data and we're going to train the model. So here's where it may differ from offline or non-auto ML solutions. Auto ML, what it allows me to do is rapidly train my data on many algorithms and many combinations of hyperparameters in a parallel way. So I can rapidly discover which are the best models and hyperparameters that fit my data. Once I do that, Machine Learning Studio is going to help me find the best model. I'll show you that in a minute, and then we can publish that model out to be consumed. And then the model endpoint, again, exposes my model as a REST endpoint, so I can start to do some inferencing. So diving a little bit deeper into the process, again, it automates that machine learning process, which is typically time-consuming, right? Running through different algorithms with different parameters and hyperparameters, and then looking at the output, the metrics, which we'll see in a few minutes, to discover which is the best combination for your data that will provide the best results. So some of the features of Azure Machine Auto ML include data preparation and ingestion. We talked about that. It does a lot of feature engineering, so it helps you select the right features for your model. That's another time-consuming process, as well as extraction. It does detection of skewed data and imbalanced data, missing values. So it helps you a lot there. Does some model selection, obviously, and validation, hyperparameter optimization, and then helps you with the selection of the model with metrics from the process itself. So for this demo today, we're going to use the Titanic data set. How many of you have done that with Kaggle or training? Okay, a couple of you. So this is a pretty famous data set. So it's the Titanic passenger list and whether or not the passengers survived. You can see here that the data has characteristics or parameters for the passengers: sex, age, their family, how much they paid for the ticket, what lifeboat they escaped on or not. And unfortunately, the body number, if they just discovered the body, pretty gruesome. So the one thing that Joel and I keep coming back to as we do more and more machine learning projects, which probably resonates with some of you, is how important it is to understand the data you're actually analyzing. So domain knowledge is essential in data science. This not only helps you understand the outcomes or the predicted outcomes, but also helps with your data analysis, cleanup, picking the correct features, and understanding the potential anomalies. Exploratory data analysis helps a lot in this area, but you also have to understand the domain or the business of the data as well to make sure that what you're seeing makes sense. So to that end, I'm a little bit quick about me. I'm a Titanic nerd. So I've been fascinated by the Titanic since I was 9 years old, and I've read dozens of books. I've traveled to museums around the world. I love the Titanic. So when I started learning machine learning, this really resonated with me quickly. And it really helped me understand the results, outcomes, and anomalies of the data as I was analyzing it, and as I will do in this demo here. So we're going to switch really quickly over to the Machine Learning Studio. All right, there we go. All right, so this is the Machine Learning Studio really quickly. So the first thing we'll just show you is loading data. So obviously this all starts with data. So the Titanic data itself was loaded here. And if I explore real quickly, you can see the data is loaded. The meat of this is really the automated ML feature we were talking about. So if I open one example here, so this is the job I ran a couple of days ago. And essentially what it's going to do is run a whole bunch of algorithms. So this is a binary classification. So I want to know whether or not they survived or not. So this is going to run a bunch of binary classification algorithms and a combination of normalization of the values themselves to try to discover which combination, which model fits best for this data. So you can see here, this uses the area under curve AUC metric, which is a metric used for binary classification. And it picked this voting ensemble, which is actually a combination of algorithms that vote against each other to try to find the best combination. But given this, that's what it determined the best model was. And you can see here as I dig in to that particular model, the explanation, you can see here it's starting to pick and tell me which are the most important features of the data, which is important to understand how that influenced the actual outcome or predicted outcome. So you can see here, being a male on the Titanic is not a good thing. That is highly predicting the survival or non-survival, but also being a third-class passenger, embarking from Southampton. A lot of third-class passengers actually embarked from there, so that's what's factoring there. And then interestingly, which I thought was interesting, is a medium-sized family contributed a lot to the outcome of the data. So as you dig into the actual metrics, you can understand the results of the model itself. So accuracy in this particular run, I didn't do too much analysis or EDA of this data. It's about 82% accurate, but if you have done this before, you'll see that also it has the F1 score and precision and recall all calculated for you here. Some other interesting things is the ROC curve, if you're familiar with binary classification. The ideal is it to be like that. So the fact that it's curved like that is okay, but we could do better. And then another interesting piece here is it shows you the truth table, the confusion matrix. So how many true positives and true negatives and false positives and false negatives were resulting in the data. So after I do this, once I pick my model that works the best, I can then publish it. So I publish the model here and then expose it as an endpoint. And real quick, I'll just show you how we do that. So I've exposed this as an endpoint, and this is Postman. So this is a little bit hard to read, but here's all of the parameters that I've used in my model. So you'll recognize age, fair. I've done a little bit of one hot encoding here. But this is representative of a male third-class passenger. So if I run this through the inference now, you could see 0. It's not going to survive, right? Predicted. But if I do a female, middle-aged, no family, third class, interestingly, it's predicted to survive, right? But if you start putting some variability in there, so now again, a female, middle-aged, but with a large family, also third class, the model predicts that this particular passenger won't survive. And that sort of makes sense if you think about a large family as mothers probably, gathering all your kids and trying to make it up to the boat. It's probably not a good situation for that person. So anyway, this is a real quick just overview of Machine Learning Studio. And if I could find my cursor here, I'll get you back to the Chrome. Okay. So this is not going the right way. All right. So last thing is pros and cons. So there's the pros on this. It's quick. It's a low barrier entry to machine learning. I think a machine learning engineer would probably be best for this. Maybe not a data science, but it depends on the size of your project. You may not have the budget for a data science scientist. Obviously, you can massively and parallel and highly scalable infrastructure. There's a lot of CPU and GPU availability, which is a big one. They've got a lot of NVIDIA processors, covers the entire ML ops as a service. So you can basically do soup to nuts machine learning. Cons, again, it's low code, no code. There's limits to that. It's like the 80-20 rule. You can do probably 80% of what you need, but 20%, you may need to bring in a data scientist or drop down into the actual code. Costs can get high. You got to really pay attention and put some limits on the amount of models you're going to train in parallel and what you're going to train it on. Vendor cloud lock-in, obvious, right? We're using Azure. AWS has its own set of tools. I don't know if anybody's used Bedrock and those sets of tools, very similar. And, again, it's hard to compete with a specialized hand-built model that's hand-tuned for a particular purpose, but this will get you, started essentially. So that's the presentation. Any questions? Yes, good question. So I mentioned earlier, there is a generative AI portion to this where you can start to build like RAG, and it has a capability of indexing and so forth.
So you mentioned vendor lock-in. Is it easy to export models?
That's a good question.
Or is it really long?
Yeah, you can export models. So for instance, you can export this model as an Onyx model, if you're familiar with that. Most of the things that they do in here, you can drop right into the Python code. And they obviously are generating Python code behind the scenes. It is using a lot of Azure libraries to do stuff, but it's not too far off.
So for feature extraction, it can automatically extract the feature for you, or you have to do something?
It will start to, so it does some things for you, like one hot encoding, it'll recognize that, it'll help you with sparse data and inputting data. It'll give you the metrics I showed you earlier, where it shows you the importance of the features. So you can start to use that to do feature extraction. To be honest with you, for most of the projects I've done with this, I've had to do a lot of it myself in, traditional Python tools, SkyKit and so forth.
The data can be fed from like external systems like Snowflake or something, or
Yeah, they have a lot of connectors in here. I mean, this was just a file they uploaded, but you can drop it in as a blob, data lakes. There's a lot of connectors to pull data in live.
how is like this different from Azure OpenAI Studio? Like,
It's a good question. I haven't used OpenAI Studio. The generative AI portion of this, you can hook into the OpenAI LLMs. So I don't know if, again, it's Microsoft, right, with the names. I don't know if it's really the same thing but good question. Yeah.
My name is Eric Konieczny, and we'll be sharing some ideas around how to tame Python, especially within the context of a large enterprise AI system. For some quick background on myself, I've been working in technology consulting for the majority of my career across both big and small companies, always in hands-on technical roles. Over the last few years, I've been focused primarily in AI/ML. So we're going to open with a potentially controversial hot take. We think that the de facto standard for AI/ML build automation is running a notebook and visually inspecting the results. Data science projects typically rely heavily on notebooks for doing all lifecycle tasks. This could include specifying dependency versions, running tests, and even remotely executing code, potentially even on production environments. This tends to make sense. Most data science efforts start as exploratory in nature, and data scientists are largely focused on the creative problem solving in science, not so much on DevOps or multi-platform build automation. Python is arguably the industry standard when it comes to AI/ML, but unlike the JVM community, where Maven and Gradle are kings of build automation, there aren't really a lot of strong industry norms for automation tools within the Python world, especially among data scientists. There are some automation tools that we do recommend using, and we've integrated heavily, which we'll talk about later, but uptick within side of the data science community is definitely lacking. Best case scenario we typically see is that a data science project might have a pip requirements.txt file within it. So reusing data science work and integrated into your own projects is even more difficult due to some other challenges. Specifically, multi-architecture and ARM64 support is lacking. If you have an Apple Silicon machine or have ever tried to deploy to AWS Graviton ARM64 machines, you know the pain. Additionally, a lot of the leading edge deep learning libraries like TensorFlow and PyTorch that are frequently used, they publish a lot of breaking updates to them. And even really popular commercially backed libraries like Mask RCNN can atrophy. So AI ops and ML ops are emerging trends, and they do help with some data science repeatability concerns, but they're more focused on things like how do I understand the data that is used to train my models? How can I version control my models? And things of that nature. They aren't really focused on the core challenge of how do I take some AI ML code and integrate it into a larger code base. As teams are transitioning experimental notebook-driven projects into production-ready systems, they often find that they need multi-language polyglot support. For example, teams might find that inference results need to be displayed in an Angular web application, or they need to integrate with a PySpark pipeline that's doing some upstream data pre-processing. As teams are trying to figure out how to integrate and cobble all these different technologies and frameworks together, monorepos are starting to become a popular choice for how to structure your code. We do recommend using a monorepo over a polyrepo for a couple different reasons. First, dealing with transitive dependency version conflicts is a lot more straightforward in a monorepo, and code sharing just works better in a monorepo. Any updates that are made to shared libraries, especially breaking changes, can be quickly and easily verified and fixed. Doing this in a polyrepo does require a good amount of CID scripting and instrumentation. The prototypical big tech FANG companies that have been instrumental in driving monorepo adoption, but the build tooling that these companies use might not be realistic for your own project's needs. Big tech firms devote a significant amount of money and resources to maintaining their monorepo builds. They typically recommend using tools like Bazel and Pants, which are, to their credit, highly flexible, but we've found is that batteries are not always included. In a lot of scenarios, you're going to have to maintain your own set of potentially complex build rules and extensions in order to integrate the technologies and frameworks that you rely on. So what are the rest of us supposed to do for our polyglot AI monorepos? In our business, we work with a lot of large system integrators. We typically see that our projects are a combination of JVM for server-side processing, web applications for UI, and then, of course, Python for AI/ML. We recommend Maven as a solid candidate for your monorepo build system. Most developers have had some exposure to Maven, broad adoption across the development community, and it's extremely well documented. For nearly every type of technology or framework that you'll want to integrate into your build, there's a high likelihood that there's a well-supported, mature Maven plugin that fits that need. Additionally, Maven recently added build cache support, which provides some level of feature parity with Gradle for incremental builds. We do recognize that there is a bit of a holy war when it comes to preference for Maven versus Gradle. For most of our clients, we tend to recommend Maven primarily because Maven's rigid simplicity often leads to more maintainable builds versus Gradle's flexibility, which might have a tendency to lead to some unmaintainable or difficult to maintain build scripts. In both scenarios, Python support in Maven Gradle is really lacking. So in order to fill that gap, we created Habushu. Habushu is a Japanese liqueur in which a live venomous viper is put into the bottle. It's also an open source Maven plugin. what we've done is come up with an opinionated, best of breed set of life cycle activities that we think applies to any Python project, and then encoded them and enforced their execution by mapping them onto a Maven lifecycle. Some of those key lifecycle activities include virtual environment management, managing your dependencies and transitive versions, consistently executing tests and reporting them in a consistent manner, packaging your code as wheels or source distributions, deploying them to the appropriate PyPy repository, and of course, because we're operating within inside of a monorepo, making sharing local modules as easy as adding a normal Maven dependency. The initial versions of Habushu relied on a combination of pip, venv, and pyenv, but we have later evolved to use Poetry so that we're in line with the latest and greatest Python standards. Poetry provides a lot of our core dependency management and packaging capabilities that we round out with inside of Habushu. Poetry could be replaced with a different tool that provides similar capabilities, such as Hatch or PDM. Really, the core idea of Habushu is that life cycle of consistent activities, as opposed to the underlying tools that are used to provide those life cycle activities. So when we introduce Habushu to data scientists, the typical reaction that we get is, well, Python's an interpreted language. We don't need to build. It'll just slow down my work, right? It's true, there is some confusion there, but ultimately, Habushu's value is that automated enforcement of lifecycle activities that would otherwise have to be manually executed, or in other cases, manually scripted out and in different ways by every developer on the team. We've taken a lot of care to make sure that data scientists can still use their native tooling for optimizing their workflow. And still, they gain all the benefits of working with inside of a polyglot monorepo structure and being able to execute a top-down root level build using Maven clean install. For projects that we've integrated Habushu into, we have seen that buy-in from data scientists typically increases as some of the benefits around an improved release cadence and velocity become more apparent over time. If you're interested in learning more about Habushu, we have a blog post on our Substack, and feel free to check out our project on GitHub. Any and all feedback is definitely welcome. And if there's any questions, feel free to reach out and let me know. Thank you.
My lightning talk, I'll be presenting a sight to behold using glasses to explore embeddings with OpenAI's CLIP model. So by way of introduction, my name is Ryan Gehl. I solve big data and enterprise AI ML problems at scale. I'm currently taking a sabbatical where I'm diving deep on generative AI. A lot of people in the AI space are looking at things like building better models, which I think of as being similar to building ovens and microwaves. My interest is in making tasty meals. What can we do with that technology today? So please reach out. I'd love to connect. My contact information is on the slide here. So I've been looking at a number of different projects, but this one in particular is the one I wanted to share today. My motivation here was it's inspired by work that was done by Simon Willison and Drew Brunig. So Simon is a thought leader in the space. He's a founder of Django, has been doing some really interesting things. There's a great talk from him from PyBay from 2023 from last fall about embeddings. I highly recommend you go and check that out. It's embeddings, what they are and why they matter. So an embedding is a point in multi-dimensional space that represents a location. Embedding is one of these cool adjacent technologies to LLMs where what you can do is, this is really coming from Google from about 10 years ago in terms of the Word to Vec paper, this idea that you can take content and convert content into an array of floating point numbers. So depending upon your embedding model, That might be 512 floating point numbers. It might be 1,000, might be 2,000. But it represents a point in space, kind of a vibe-based point in space of the translation between the content and again, this point in space. So why does it matter? The reason it matters is that it enables some really interesting things to happen. So similarity search, that'll be the focus of the first part here. Similarity search, retrieval augmented generation, and clustering. So the first thing I did was I said, I'm going to, so here's what I built. I downloaded 30,000 pairs of glasses from Glasses USA. And if we take a look at the little demo on the right-hand side, notice what I'm doing is that actually, let me do it this way. So I downloaded 30,000 glasses. I then said for each pair of glasses, I'm going to calculate the embedding using the clip model. And I stored that in a SQLite database using Simon's tool dataset. I then built 2 pages. One of them loads 9 random pairs of glasses. And then if you click on Find Related, it'll show the closest images in embedding space. Now, the way it does that is it uses the Facebook AI Similarity Search Library, FAISS, to do that. And you can see here I'm calculating the L2 score, which is the Euclidean distance between those embedding points in multidimensional space. So yeah, so if you look at this, like look at the screenshot on the right-hand side, this is remarkably effective. I was amazed at how effective this technique was. Next from there, I said, let me use a technique called principal component analysis to reduce the multidimensional space down into something smaller. And I said, using PCA, let's find out let's find the first 2 dimensions and then plot them on an XY coordinate graph. And what you can see here is, has anyone noticed the little lung on the left and the lung on the right? As I'm mousing over these different points, notice the clustering that's happened, right? Sunglasses are on the right, regular glasses are on the left. Next, what I did, and this one requires a little bit of explanation. So imagine there are 2 pairs of glasses that you're interested in, right? Hey, I like aspects of one versus the other. And each of those glasses is represented by a point in multidimensional space. So now imagine you have 2 points in multidimensional space and you have a line segment connecting the 2. Now chop that line segment up into mark it every 20%. At each one of those points, find the closest related glasses at that point, right? So that's what I built. So here you can see, here's your hero pair 1 on the left, your hero pair 1 or pair 2 on the right. On the left-hand side, these are the 5 glasses that are closest in embedding space to the original pair. These are the ones here on the right-hand side that are closest to the original pair 2. So what you see in between is, well, if you want an 80-20 split, if you walk 20% of the way toward pair 2, so mostly pair 1, a little bit of pair 2, the glasses start to look like this. Or if you're at, 20-80 the other way, it looks like that. So taking a closer look here, 60-40, right? What have we done? We're still retaining, it's retaining some of the sunglass feel. It starts to pick up the coloring of the frame. I mean, this is weird, wild stuff, right? It's remarkably effective. Again, I'm not providing any text. There's no text description around any of this, right? There's no facets. There's really no metadata at all. All I've done is fed in images, gotten the embeddings, and then are finding similarity, finding other embeddings that are close. It's crazy. So next what I wanted to do is I said, okay, can I visualize the similarity search? Right. So what I did was I went back to step 1, the same thing I did at the very beginning, and I said, let me modify the page in the following way. Right. So what I've got here is, instead of displaying a grid of random glasses, I've got the random glasses listed. Then using principal component analysis, again, what I did was I said, let me display the first 10 dimensions, but rather than displaying the dimensions as a number, let me color it using a legend of dark purple as a large negative number and white is a large positive number. So you can see here, you've got random glasses, and then for each one of these dimensions, I would say, yeah, these are pretty randomly distributed, right? If I select a pair, so I selected this pair and said, find me the similar glasses, notice if you just look at the glasses themselves, they are very, very similar. And you can tell from the L2 score, they're all right in the same neighborhood. But the thing that's fascinating is now if you look at the PCA values, right, the dimensions, notice, oh, it's all dark purple for the first one and all sort of medium purple for the second, right? So to me, this is a great way to say, okay, this technique, something is going on here. This, for me, this is a way to visualize what's actually happening behind the scenes. So again, kind of a closer look at this, you know, if on the left-hand side, I picked a pair of sunglasses, notice the similarity scores and that the histograms line up. And on the right-hand side, just a pair of regular glasses, same deal. Everything kind of lines up. Then I said, let me do the same thing for the blend technique, right? So I have displayed the hero pair at the top, the pair 2 at the bottom, and what I would expect, and actually what you can see is it'll start lighter. So if you're going from light to dark, you can see the intermediate ones blending that. Or if you're going from dark to light, you see that as well. Yeah, so this is cool, wild stuff. I think this is great. I'm really excited by this. I do have one other bonus thing to mention here, right? The model that I'm using to drive all of this, OpenAI Clip, connects text and images, right? So what that means is not only do the words cat and feline map to the same space in embedding space, but also a picture of a cat and the word cat map to the same place, right? So that unlocks some really interesting things. So here's what I did. I added a text search box, and then I'm displaying the results with the visualized embeddings. Now, the important thing to remember here is I did not provide any metadata for the glasses images. I just provided the images themselves. So I didn't say size or shape or color. I didn't give it any of that. I just gave it the image. All right, you ready to see what this looks like? Okay, so if I search for Aspen, Colorado, look at what gets returned. Do you notice anything about the glasses? Yeah, seriously. It finds a bunch of ski goggles. To me, that's amazing, right? That the text Aspen, Colorado in embedding space is close to the embedding space of where the ski goggles are getting mapped into. Another example, I put in Eli Manning. So it's a little hard to see on the slide, but let me blow this up. The closest pair that it found was a NFL branded New York Giants pair of sunglasses. I know. Next, I searched for cheetah. Take a look, right? Pretty crazy stuff. Now, for the bonus section, I will call out a couple things, right? I am cherry picking some of the best examples, number one. Number two is if you take a look at the L2 scores, the Euclidean distance between the text and images is not as tight as what we were seeing in the earlier examples, right? The earlier examples of finding similar images, they were all sort of sub 5, sub 10. Here, it's pretty far apart. But again, this is remarkable, right? The idea that if I put in the word cheetah, all of a sudden I'm finding glasses that are somehow vibe related to what I would think a cheetah would look like. That's astounding to me. So embeddings are amazing things. I would say a key takeaway from all this though is, okay, so I'm showing embeddings using glasses, but that's not really the point, right? I could have done any other image, or I really could have done any text as well. So this same technique is the fundamental underlying technology behind things like retrieval augmented generation. So yeah, there's some really exciting stuff happening in the generative AI space. And yeah, again, feel free to reach out. My contact info is on the slide. And thank you very much.
Thanks for coming, everybody. I am the dumbest speaker of the 5, so they saved me for last. So hopefully I won't put you to sleep. Today I'm going to talk about AI hallucinations. What are they and why are they important? So the Gehl definition of AI hallucinations are basically incorrect or misleading results that AI models generate and present as fact. The term's been around since the 2000s, but it meant something different. And then in the 2010s, it morphed, and then it became popular recently because of all the generative AI chatbots and image generation. So it got a front row in the last couple of years. So I want to go through some examples of hallucinations. So this is me asking ChatGPT, which is with DALL-E under the covers, to generate an image demonstrating my company's ability to rescue broken offshore projects. So talking about, why we're good at, helping out, fixing projects that are broken. And I gave it a bunch of ideas here, and it's pretty cool. I think it's a really neat image. I think it's pretty interesting. But as you can see on the building, it didn't spell my company name right. So I was like, what's up with that? So I said, that's great, but could you please put my company name on the building? So then it generated me a whole nother image, which is not the one that I really liked. This is a totally different image. I didn't say change the image. I just said put my company name on the building. And then it put some random other words on there, right? So there's some, a lot of this is the image generation doesn't really understand text is the reason why, but it's an example of a hallucination. So another one is I had a data set, a CSV file, and these are all real world examples in Joel's life of experimenting with machine learning and AI for the last year. So I had a weather CSV for a place called Port Dover. It's in Canada. And I imported it into ChatGPT, and I was like, oh, generate me a bar chart of the average wind speed per day in January. And man, awesome, right? Like, that's really cool. I didn't have to do any coding or any work. And then I asked it, if you can see over here on the right, how many days was the wind speed over 15 miles an hour? And it was like, there are 5 days in January where the average wind speed in Port Dover was over 15 miles an hour. I'm looking at the chart going, WTF, right? Like, there's nothing in there. There's not a single day over, right? So then I asked it again, right? It was like, yeah, there were no days. But this time when I asked, I did say, what was the average wind speed? So I wasn't clear in my first question. So this could be a prompt engineering problem, or it could be a hallucination. But the fact that it came back with the average wind speed said, to me, it was clearly confused. And if you look at the Python code, I know why, but I didn't want to spend an hour doing that. It's a 10-minute talk, so I had to kind of skip it. So, but there's an error in the Python code. Training issues, right? So you guys have seen the lot of these out there on the web. Kind of a lot of these models, they use humans to train them, right? There's real feedback models, and kind of talking about the intentional versus based models. So intentional means like they're trying to make them representative of all of us, right? And so they're putting in like, oh, it shouldn't, it should be women, it should be people of different backgrounds, but the era isn't understood by the AI, right? So in this case, like women NFL players, or colonial Americans maybe didn't look like that. The founding fathers, maybe they got confused with the Hamilton play. I'm not sure, but these all things can happen when you put humans mixing in with the machine, right? So the last one is very near and dear to me because my Tesla did try to kill me recently. I've been an early adopter of full self-driving. Don't tell Elon I'm talking about this. And in the early days, full self-driving was 3,000 lines of C++ code. It was explicit. It was like, if there's a double line, don't go over it. If there's a turn here, do this, do that. And it worked pretty well, but it was kind of clunky and it was not really smooth. Recently, they came out, so those of you that are nerds like me, came out with 12.3.4, first one based on a neural network. So I was like, yes, this is going to be cool. This is going to be exciting, right? Not going to be any hallucinations, right? So this is my car driving home. My left turn is coming up here shortly. You can see on the map down there where it's supposed to turn here soon. There's a double yellow line. This is a 4-lane highway near my neighborhood. And right about here, things go sideways. Gotta take over because you gotta get through. So, yeah, if I wasn't to take over, there was a car coming in that lane and I would be dead. So that never happened with the explicit C++ code, for the record. It never crossed the double yellow line. It might have pulled out in front of a car, but it didn't cross double lines. So this is a likely reason for this new neural network had a hallucination. So why do these happen, right? So one thing is insufficient, outdated, or low quality training data. So really it's all about the data. Overfitting, and this is a problem Greg and I have had, is like if you don't have enough data for all the scenarios that you're looking for, the model can overfit, and that's very bad, right? So in this case, we were looking for weather delays in shipments. We had like 1,000 no delays, and we had like 200 or maybe 20 delays. It was really tough to do that. Use of idioms or slang expressions, and then adversarial attacks. Somebody talked about that early on. That actually does happen. So that's like where bad guys try to mess with your AI. I think, was it Ryan? You used the stop sign with the post-it note on it that said go. So these are some of the big reasons this stuff happens. There is a leaderboard. It's the GitHub link I have here. And basically it kind of ranks using a tool, which may or may not be perfect, all the popular models and what is their hallucination rate, right? And so you see at the top, GPT-4 Turbo is the lowest rates right now as of 3 days ago when I took the screen cap, and it's 2.5%, and all the way down up to 5%. The best models in the world have been hovering around 3 to 5%, and they've really been struggling to get better. There's certain people say it's going to go to 0, it's going to go to such a little number, it won't matter. And you have an argument to make in a car. Like people today, they drive with their phones like this, they're not paying attention. At what point does the computer killing you less often than all the bad humans out there killing you? I don't know. I'm not a politician. That's not my argument to make. I'm an engineer, right? But these are good to watch and good to understand that they do happen even in the best models. So why does this matter? I've been writing software for over 30 years. My customers expect my code always to work. If something breaks, they expect me to reproduce it and to fix it. They don't expect the same problem to ever happen again, right? Ever. With AI and neural networks, including LLMs, you don't always get the same result, even if you ask the same exact question. Now, you saw my question about wind speed. It was a little different, so maybe I was cheating there. But I can't tell you how many times I've asked the same question and got a totally different answer. In fact, with ChatGPT, when you have to model something, it's used totally different algorithms multiple times for me. And I'm like, why did you pick random forest this time? And why did you pick, whatever the next time? So if something breaks, you can train your model, but that could then cause other unintended consequences. The answer you usually get, depending on the model, depending on the algorithm that's used underneath, a confidence level or a percent. Often people don't share that model. They just, like ChatGPT just comes back and says, this is the answer. It doesn't say, I'm 72% sure this is the answer. I'd like our software to be a little bit more transparent, right, that we write. So what should we do? For now, I think the best thing to do is to look at current AI ML as human assist. So things where safety or money are at stake, I would make sure a human reviews it. Leverage that probability / score when available so you can kind of get a sense. Consider using more than one model. So you can take multiple models and then compare the results. I think Greg showed that in AutoML where it would just go feed it into a boatload of models. Now, maybe that's why it costs so much. I like this one a lot. I don't think it's popular, but it's popular in Joel's head, is use the hybrid model with business rules and then compare the results. So take the old school business rules, like the C++ code, and then use that model, and then like maybe have a little tug of war. Who do you trust? And then Ryan talked about this, use RAG, retrieval augmented generation, get more context in your specific world. You can really fine tune a generalized LLM to be much better at your specific domain, and that'll help reduce your hallucinations. That's all I got. Thank you. Any questions? I don't want to ask the dumb guy questions. I like it. Everyone's tired.
You answer all their questions.